Hello, my name is Raphorn. I am an associate professor of finance at Pennsylvania State University, School of Graduate Professional Studies. Alright, so we're going to cover this chapter, the capital asset pricing model. We call this the CAPM, right? The CAPM or CAPM. This is a very powerful model, and it has been around for over 40 years. Well, this model is important because it identifies the equilibrium that underlies all of the modern financial theories. So every financial theory is ultimately based on this model. Well, this model is derived using principles of diversification with simplified assumptions. Well, by now you should be familiar with the concept of diversification, right? You are diversified when you hold multiple securities at the same time, and the basis of this model is diversification. The people who came up with this model, there were a number of people. They were working on the same idea independently. Markowitz, Sharpe, Lintner, and Mawson. So these are the people who came up with this model. Well, there are a few assumptions for this model. I'm gonna go over these assumptions. You probably don't need to memorize all of them, but you have to have an idea about these assumptions. The first assumption is that individual investors are price takers. That means that you assume that each individual investor is so small that they cannot influence prices. So as an individual investor in this model, you are a price taker. You take whatever price the market is giving you. Okay, you cannot influence prices. Second assumption is that this is a single period investment horizon. Okay, so you look at one period only. Investments are limited to traded financial assets. Only financial assets that are tradable, that are traded, are applicable here. Okay, if you have something that is not traded, something intangible, something something not that cannot be traded, then it's not included in this model. No taxes and transaction costs. You may say, hey, this is unrealistic, and you are right, but at this point we're going to make this assumption that there are no taxes and transaction costs. Later on we can relax this assumption, but for the time being we're going to assume that there are no taxes and no transaction costs. Information is costless and available to our investors, right? In reality, when you want to get some information, you have to pay for the information, so it's not free. But in this model, we're going to assume that information is free, it's costless. Okay. Investors are rational, mean variance optimizers. Okay, so what does that mean, mean variance optimizers? It means that you try to maximize the expected return, right? And you try to minimize the risk of your investment. That's the meaning of being a mean variance optimizer. The next assumption is that there are homogeneous expectations. So basically, you say that everyone has the same information, has the same belief. I should say, has the same belief. So everyone, there's no disagreement here. Okay, the result of those assumptions is that all investors will hold the same portfolio for risky assets, and we're going to call this the market portfolio. The market portfolio contains all securities and the proportion of each security is its market value as a percentage of total market value. I know that this statement may not make much sense to you right now, but as we go over some examples later on, it should make more sense. Essentially, this is what the CAPM is about. If you look at this equation right here, the expected return of security I, which means any security, is equal to the risk-free rate, right, plus the beta of that security times the market risk premium. Okay, the difference between the market return and the risk-free rate is what we call the market risk premium. So this is basically the CAPM, and you probably have seen this equation in your previous finance class. Alright, graphically you can represent the CAPM this way. You begin with the risk-free rate right here, right, and you have the market portfolio right here. At this point, this is what we call the market portfolio, right, and this is the SML, or the security market line. At this point, if you hold the market portfolio, then you get this market return, right, and by definition the beta of the market portfolio is 1.0. Right. So what you can do is you can compute the slope of this SML, right? What is the slope of this SML? Basically, it's just the vertical distance right here divided by the horizontal distance here. The vertical distance is basically the difference between the market return right here and the risk-free rate, right? That's the vertical distance, and you have the horizontal distance, which is 1. Alright, now let me show you one application of the CAPM. This is the CAPM represent graphically, and we call this the security market line, right? This is the security market line. So in equilibrium, every security should fall on this line, right? Now let's assume what happens to this stock. If you look at this stock, you can see that it doesn't fall on the line, right? It's above the security market line. What does that mean? Well, if you look at this particular spot right here, right, you can see that given the risk of this security or this stock, the risk of this stock is 1.2, you know, as represented by its beta. The risk of the security is 1.2. Right, so according to the CAPM, according to the SML, given the risk of the security, then the return should be 15.6. Okay. However, this stock is above the SML, which means that it's giving you this much in return, 17%. So basically, this stock is giving you more than it should, right? According to the CAPM, in equilibrium, it should be giving you 15.6% given its risk. But in actuality, it's giving you 17%. So it's giving you more than it should. How do you characterize this stock? You characterize this stock as underpriced or undervalued, right? Because this is something that investors should buy because it's underpriced. And you can see that you can say this stock has a positive alpha. Positive alpha means this is giving you an abnormal return. An abnormal return is something that you get beyond what is predicted by the model. Well, the question is, how realistic is the CAPM, right? In equilibrium, all securities should have 0 alphas, right? That means every security should be in equilibrium, right? You should have 0 alphas. Now the question is, in reality, do you have 0 alphas? Well, it's not perfect, but this is one of the best models available. So that means that not every security has a 0 alpha, but many of them do. Okay. Is the CAPM testable empirically? There are some issues here. One issue is that proxies must be used for the market portfolio. And the idea is that when you test the CAPM, you have to identify the market portfolio. And the market portfolio has to include all kinds of assets. Now, in reality, you cannot identify the actual market portfolio because you don't have a market that includes all securities. So most of the time, people use the S&P 500, or some kind of a stock market index to represent the market, which technically is not accurate because that's just stocks, right? You don't include bonds, you don't include other things. So actually, the CAPM may not be testable, strictly speaking. However, CAPM is still considered the best available description of security pricing and is widely accepted. So in spite of all the weaknesses of the CAPM, it is still very popular, and many people, many companies, many people in academics continue to use the CAPM. Thank you very much for your attention. This is the end of the presentation.